All right, this is Lewis Structures Part 2. I am going to do another ionic, which is here, and another covalent. And I've enlarged the boxes, hoping that I can fit it all in. So the first step for an ionic is to draw each of the atoms. Sorry for the bell ring.
Quick announcement, bus 27 will be for bus 5 today. Again, if you take bus 5, your bus today will be bus number 27. Thank you.
Okay, so we have 3 magnesiums. And in our previous question, we knew that magnesium was in family 2, so it has 2 valence electrons. We have nitrogen, and we have 2 of them. And each nitrogen has 5 valence electrons because it is in family number 5. So what will happen is there will be a transfer of electrons. 3 will go to one nitrogen, and 3 will go to the other nitrogen. And that is the transfer. And then the last step is to write it in its new form. And what we end up with is Mg 2 plus each one. And I am going to put a bracket around that. And I have 3 of them, so I'm going to put a 3 in front. Then we have our nitrogen, and each nitrogen has received 3 electrons, so the charge is 3 minus, and we put the brackets around it, and there are 2 of them. Okay, so that is how you write the Lewis structure, which really is Lewis dot structures showing transfer. That's really what that is. Now, let's do another covalent, which is this one down here on F3. Remember the steps. Step number 1, valence electrons. Okay, you have nitrogen and you have fluorine. Nitrogen has 5 valence electrons. There's 1 of them, so it's 5. There are 3 fluorines, and each of them has 7, and that's because they are in family 7. Then you add that up, and there are 26 total valence electrons. Octet electrons, this is what we call step 2. You have a nitrogen, there's 1, and you have fluorine, and there's 3, and each of them would like 8 valence electrons, unlike with hydrogen where it was only 2. So 1 times 8 is 8, 3 times 8 is 24, 24 plus 8 is equal to 32. Okay? Then we look for bonding electrons. So number 3 is we have our octet electrons minus our valence electrons, and that is equal to our bonding electrons. So we have octet electrons 32 minus valence electrons 26. 32 minus 26 equals 6, and that's how many bonding electrons there are. You shut it all the way. Okay, so then you take your bonding electrons and divide by 2 to find out the number of bonds. So we had 6 bonding electrons divided by 2 is equal to 3. And that means we have 3 bonds we have to account for. Right? So then the next step was to draw. And remember, whatever's listed first is usually your central atom. And we have 3 fluorines and we have 3 bonds. So I am going to place a fluorine on each side.
Mr. Budden, call extension 2055. Mr. Budden, call extension 2055.
Okay, that is the setup. We've got all of our atoms accounted for. We've got a nitrogen and 3 fluorine. Then we do our next step. Well, remember 5 was draw it, which I did. 6 is to figure out how many non-bonding electrons there are. And the way that you do that is you take your valence electrons minus your bonding electrons, and that equals your non-bonding electrons. So in this case, we have 26 minus 6, and that equals 20. So we have 20 non-bonding, and I ran out of space. So we have to start adding electrons to this molecule until we have octet for every one of the atoms. So let's start with nitrogen. Now remember that each of these lines is 2 electrons. So 2, 4, 6, and then 8. Okay? Then each fluorine needs 8. So here's 2, 4, 6, 8. And this fluorine also needs 8. So 2, 4, 6, 8. And same with this fluorine, 2, 4, 6, 8. Okay, now everything has octet. All of them have 8, which is what they originally wanted, okay? But what we're going to do is just count to make sure we have a total of 20 non-bonding electrons. And so I am going to just kind of circle them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's 20 non-bonding electrons. We're all set. Now, again, I do not want you to circle. I just did that to show you.